you can see in this video, egg tapping is a traditional game where two players hold the boiled egg. Actually, one player collision to another eggs and one egg cracking. And the question was from us to say which one we win. In the first, I give you some information about this game. After that, in theory 1, we talk about the eggshell and how outside of egg can help us understanding this problem. And in theory 2, we go to inside of the egg and how after boiling the material can affect on this phenomenon. And after that experiment and the final, maybe if I have time, I suggest some economical introduction. Okay, we have egg A, egg B. It's clash to egg B and have crack. We have two parts. Part 1 is eggshells. We talk about that, and part 2, it's about inside of the egg. Inside of the egg, we have a yolk, and we have a white part, aluminum. Talk about the eggshell. Actually, the different eggs may have a different eggshell. And as you can see, maybe in this way and in this way. For example, we have 2 eggs. And when we have 2 eggs, we can suggest that 2 different radius. And the geometrical stiffness, when the radius is increased, it's decreased and have an inverse. Reverse relationship with each other. Coming to see what happened outside of the egg. 31, surface physics. Actually, in the first coming to talk about young modulus is stress divided by the strain. And works like it and everyone knows that. For example, we have eggs and we apply first to it. If we divided these eggs in 2 parts and we focus to the part that we apply the first to it, we have actually, if you can see these rings, before these rings actually have an undamaged eggs. And after that, the tension is starting. And for different eggs, it is different. And we want to see what's happening really in the geometrical part of eggs. Eggs have a thickness, and we should suggest that. And because of these rings, they have applied the first to the eggshell. And this first is equals stress times thickness times number p times the radius of this rings. How to see it better? We apply first to it and the eggshell, these rings first to eggshell and have a angle with x-axis. It's alpha. And before it's breaking, before it starts to crack, the f cosine alpha is equal to f. But when it's starting cracking, when real egg start crack, actually, when the stress that the egg starts to crack is equal 2 times young modulus times energy required to break atom bonds. You know, energy of atom bonds for breaking. And Number P and C is a special length of break we come with experiment, and this is from Mr. Grace. And when F is equals to this, it's starting to crack. Come to see it better and analyze it. Okay, we have egg. That's, as I said to you, the R can change for different eggs. We have different R, and this rings after, for example, different places, apply first. And from the geometric R is equal to this. This is, and as you can see in this movie, when the R can change, and all of the terms of relationship with each other. And alpha, angular alpha is equals tangent inverse for the derivative R. And the F is big. F equals that, and relationship with thickness, Young modulus, and theta. And when actually two eggs collapse to each other, the same force to each other. What happened? What happened? Will one of them starting crack? Actually, when the different egg have different Young modulus and different theta, and which one the F, for example, applied to it, and is it's equal that or more than it, that egg start to crack. Coming to theory 2, and I really love it. Actually, what happened after boiling, and it's so important, and we should talk about it. We have an egg. It has an elastic property in the white of the part of the elasticity property, and it is so important. The yellow part of yolk has a dashboard. Work like a dashboard. We can model it like a dashboard. For example, the white part of it, as I say, have elasticity, and the yellow part of it, we can give it like a dashboard. And if we modulate the white part and the yellow part, we can model it like this. And it's when you boil the egg, viscosity is increasing. And now I want to see how can it help to us. Actually, when we solve it, we can find the stress in time, and equals with Young modulus, viscosity, and the strain. And if we apply the constant stress to it, we can find the strain from this equation. And this equation gives us what? That is a real important question. Actually, when you get a number and write this table, you can see in time t the strain increasing after time. And it means works this elasticity and this dashboard like an anti-shock. And it's so important, and many of researchers don't care about to this part. Okay, we have two eggs. One of them, the yellow part is near than the point we want to apply force, and one of them is the distance is more than, and it's far. Our theories say to us that for example, this is far, the elasticity is more. And this is have a yellow part in that point. We have elasticity and dashing and two anti-shock. Because of that, our theory says to us possibility of breaking A is more than B, and maybe B will be win. And come to experiments and see. Okay. So experiment setup. We have a surface and take it with bubble, for shook, and we have an egg tarring with play dots for keep it, as you can see in this picture. And we have a flag, and the egg, we keep the egg like that, and you can see in this. And as you can see, we kept it. Okay, the velocity is, for every egg is constant when for both egg, we have a reason, but actually we buy both the egg for micro. Okay, we have three. One of them is the widest section is up, and the shortest section is up, and wide section another one horizontally, and another one wide section is up. And in this three-way, you can boil the egg, and the yolk go up or go down. And we want to see in the experiment